Today at 3:15 a.m., Ukraine took a massive hit by a huge missile. Russian engineers started the cryogenic pre-chill sequence. Ukrainian accounts say their reconnaissance teams had watched the site for 48 hours and were ready to exploit the brief window when the silo doors would open and the missile's support systems would be exposed. The opening doors were the signal. A $100 million launch installation would be internally disabled in 47 seconds by 4 small $2,000 FPV drones from an OSA quadcopter team. Ukrainian military intelligence reportedly intercepted data indicating a diagnostic test, not a launch. This meant the doors would be open, exposing vulnerable conduits and equipment. Based on this assessment, Ukraine's SBU security service and an SSRU special operations unit launched a plan to isolate and attack the exposed subsystems. 3 miles from the silo, 2 SSRU vehicles faked a traffic accident to block the access road, delaying ground response. 4 7-inch OSA FPV drones launched from a hidden compartment and lifted into the foggy air. Each carried a shaped charge warhead with a small C4 fill, enough to puncture critical points. The dense fog was key, reducing visibility and scattering radar, complicating air defense targeting. At 3:15 a.m., the silo doors opened. The engagement began. OSA-1 entered the perimeter directly, its signature unmasked. The expendable drone was the opener, intended to provoke an electronic warfare response. As OSA-1 crossed the inner line, a Russian EW suite identified as Krasuka jammed its control link and disabled it. The FPV feed cut out. This anticipated loss achieved its goal. It forced the EW system to concentrate its jamming power on one axis and revealed its main lobe and effective band for the subsequent wave. With the jammer fixated, OSA-2 and the remaining pair maneuvered. OSA-2 climbed and presented the largest radar cross-section it could, acting as a second decoy to draw a long-range shooter. A nearby S-400 battery answered, launching a 48 N6 surface-to-air missile. The intercept destroyed OSA-2 instantly. The exchange traded a $2 million interceptor for a $500 drone. But the real currency gained by the attackers was seconds. The long-range shield and the principal EW node had both engaged, creating a brief window for the remaining 2 drones to penetrate. Drones OSA-3 and OSA-4 entered the short-range defenses, a deadly zone monitored by Tor M2 and Pantsir S1 systems. A Tor radar detected OSA-3 5 miles out and fired a 9M331 missile. The Ukrainian pilot dove the FPV drone from 50 feet into thick ground fog, scattering radar and breaking the guidance link. The missile self-destructed. This extreme low-altitude maneuver, exploiting clutter, defeated the fire control system. The reprieve was brief. The final defense, a Pantsir S1, switched from precision fire to area denial, launching a ripple of 57 E6 missiles to create a lethal fragment field before engaging twin 30mm cannons. OSA-3 was destroyed in the fragment cloud. The Pantsir then focused on OSA-4, which sustained near-miss shrapnel damage. Its FPV feed tilted, audio whined, and motor output dropped, causing the drone to pull right due to partial propulsion failure. Tactically, the last drone was now wounded, destabilized, and exposed over the target. At that point, the Ukrainian pilot, identified by call sign Kovil in the transcript, made a choice based on the drone's failing control characteristics. Rather than fighting the roll and yaw, he converted the damage into a flight profile the tracking computer did not expect. He forced a tight corkscrew dive, using spiral motion and the silo's superstructure to break line of sight. The maneuver reduced the fire control solution window for the Pantsir's guns. When OSA-4 reappeared on the Russian operator's optic, it was already aligned on a vulnerable component. By 3 hours, 15 minutes and 47 seconds, the shaped charge had perforated a 5-inch cryogenic line carrying liquid refrigerant, described as liquid nitrogen, near minus 320 degrees. And an uncontrolled spill began across adjacent subsystems. The resulting thermal shock drove uneven metal contraction, cracking welds and stressing circuit boards. Ukrainian sources claim a short circuit then propagated into the warhead handling architecture, causing a sympathetic detonation of conventional stacks without nuclear yield, deforming the 48-ton launcher and registering an estimated local seismic blip near 1.9. When the haze cleared, the site's main launcher was described as an 80-foot heat-twisted mass of steel. Debris from the long-range and point defense units lay across the perimeter. The operational impact, claimed by Ukrainian analysis, was twofold. First, the loss of one launcher represented a significant hit to a limited system, with estimated manufacturing throughput measured in single digits per year. Second, the neutralization of the site removed a large air defense coverage disk, creating a corridor that adversaries would reassess in their targeting. Ukrainian reports framed the attack's political and logistical effects. Communications at the complex ceased for hours, and testing at other facilities was reportedly paused for investigation. A likely diversion of high-end air defense assets from the front to rear areas for homeland protection was assessed. Publicly, the event was called a training mishap, while domestic social media showed the blast. Kiev's measured statements contrasted with official silence, reinforcing Ukraine's message that coordinated, inexpensive systems can breach the protection of large infrastructure. The simple cost calculus reveals significant asymmetry, and it played out in just 47 seconds at Kapustin. 4 drones, approximately $2,000 total, were exchanged for disabling a $100 million launcher and disrupting a multi-billion-dollar air defense network. Even allowing for estimates and uncertainty, the attackers forced the defender to waste high-value interceptors and reveal their electronic order of battle. Separately, the narrative shifts to a second operation involving the $10 million Krasuka 4 electronic warfare vehicle. This scene moves from a fixed site to a moving convoy, covering an offensive approach. The compromise began not via a sensor, but with a soldier's social media video near the vehicle. Ukrainian cyber analysts reportedly extracted GPS metadata with a small error margin and built a targeting solution without emitting. At 3:30 a.m., the 2-layer deception began. At altitude, 5 jet-powered Banshee decoys climbed and broadcast a fighter-like signature to force the sector's radars to look up. Near the ground, 10 FPV drones dropped to approximately 30 feet on terrain-hugging routes, running preloaded waypoints plus a visual template of the EW antenna for terminal recognition if GPS degraded. At 3:32 a.m., a Tor M2 in the convoy engaged the decoys and downed 3. That engagement illuminated radar and guidance emissions the Ukrainians recorded. Conscripts scattered. Naval infantry deployed handheld drone jammers that severed control links to 2 low-flying FPVs. At 3:33 a.m., Ukrainian electronic support, having captured frequencies and timing, cued a designated FPV digital sniper to saturate Krasuka 4's receiver front end, whiteout blinding the node. 7 FPVs shifted to silent run, inertial plus stored maps, while 3 were retasked to suppress infantry who had revealed positions by fire and jamming. At 3:34 a.m., a Berev A-50 arrived on station and cued the Tor with look-down targeting. The Tor launched again. The lead FPV executed a decoy dance, deploying a fiber-tethered radar enhancer that stole the missile off the swarm and detonated it off-axis. At 3:35 a.m., a wolf pack of FPVs hunted the quad bike teams in the tree lines, striking 2 teams and forcing the others to break contact. At 3:36 a.m., 6 FPVs converged on the primary Ural 4320 EW truck. Using the antenna's visual fingerprint for terminal lock, the lead drone detonated a small fragmentation charge inside the enclosure, producing overpressure, shrapnel, and secondary fire that disabled the system. Perimeter radios fell silent. Escort coordination degraded. By 3:40 a.m., with the EW shield down, T-90 and BMP-3 elements were exposed to accurate fires. Fuel and ammunition trucks stalled. Ukrainian forces reportedly counterattacked during the withdrawal window. The two actions, at a silo complex and a mobile EW convoy, share the same operational logic. Both employed limited low-cost platforms to force expensive defensive reactions, gather targeting data, and then strike high-value targets. They relied on a layered plan of electronic support, decoys, and precise terminal guidance, not mass firepower, aiming to gain seconds by making defenders react off-timeline. The engagements revealed key tactical lessons. In the first, OSA-1 and OSA-2 were sacrificed as consumables to engage EW and long-range air defense, reducing complexity for OSA-3 and OSA-4 in the inner ring. In the second, airborne decoys and a fiber-tethered radar enhancer diverted missiles, protecting the core swarm. Both cases involved pilots and operators exploiting environmental fog, line-of-sight barriers, or structural features like vehicle enclosures to degrade enemy sensors and maximize the impact of small charges. A key strategic lesson emerges. The cost-effectiveness of defense matters when expensive systems repeatedly face inexpensive threats. Every use of long-range interceptors or high-end radar provides the attacker with exploitable data. Over time, this data allows enemies to precisely tailor jamming, terminal profiles, and decoys to the specific radars and seekers in the battle space. The transcript frames the outcome in cost terms: roughly $2,000 of quadcopters against a $100 million launcher, and in the second action, a small set of FPVS against a $10 million EW asset and its escorts. Even allowing for optimistic accounting, the point stands that the defender was compelled to spend munitions and expose its architecture at high cost, while the attacker risked low-cost airframes and modular payloads. By dawn today, both scenes end the same way. Not with large formations in view, but with static shots of disabled equipment and interrupted command networks. The immediate fires and smoke are tactical. The more consequential effect is operational tempo. Who can reconstitute, who must redeploy, and which corridors open or close because a fixed shield has a new hole. These accounts contain contested claims regarding internal detonations, damage, and command choices, and should be viewed as operational narratives from Ukrainian sources and battlefield feeds. However, the core method aligns with modern small UAS warfare: isolate, distract, measure, and strike the critical system node. As new defenses adapt, different radar modes, tighter emission control, faster handoff between layers, the same question will drive the next iteration on both sides. Will low-cost swarms and tailored decoys continue to buy the seconds they need inside layered air defenses, or will improved sensor fusion and counter-UAS tactics erase that window?